It is possible that the universe is not as stable as it looks, that the empty space all around you is resting in a state that only seems permanent, like a ball in a shallow dip near the edge of a cliff, and that one day, without any warning, it could let go. Physicists call this idea vacuum decay. Start with what a vacuum really is. Empty space, the void between the stars, is not truly nothing. It hums with quantum fields that fill all of existence, each one carrying a faint background energy even where there is no matter and no light. The vacuum is the lowest energy state those fields can settle into. Picture the energy of those fields as a landscape of hills and valleys. The vacuum is a ball that has rolled down into a valley and come to rest. As long as it sits at the bottom, everything is stable. The laws of physics we know hold steady, but not every valley is the lowest one there is. Here is the danger. Our vacuum might be sitting in a valley that is not the deepest one, a higher dip with an even lower valley beyond a hill. Physicists call our state a false vacuum and the deeper one a true vacuum. If a lower state exists, the universe would, eventually, prefer to fall into it. This is not idle speculation. When physicists measured the mass of the Higgs particle and the heavy top quark and fed the numbers into their equations, the answer landed in an unsettling place, right at the boundary between a stable universe and a merely metastable one. Our vacuum may be living on the edge. If a deeper valley exists, why are we still here? Because a hill stands between us and it. To roll from the false vacuum to the true one, the universe would have to climb over an energy barrier it does not have the energy to climb. By the ordinary rules, it is trapped safe for as long as the barrier holds. The quantum world does not respect barriers. Through a process called tunneling, a quantum system can pass through a wall it could never climb, simply appearing on the other side. Given enough time, a tiny patch of our vacuum could tunnel through that hill and find itself in the true vacuum. And that is where it begins. The moment a patch tunnels through, a bubble of true vacuum appears, perhaps smaller than an atom. Inside it, the fields have fallen to their lower state, and because that state has less energy, the bubble is favored. It does not stay small. It grows, and the energy released drives its wall outward with terrible speed. The wall of the bubble accelerates until it races outward at very nearly the speed of light. Anything it sweeps over is engulfed instantly. And because nothing can travel faster than light, no signal, no warning could ever outrun it. The first you would know of it is never. It would already be over. Think about what that means. The bubble could be expanding toward us right now, from somewhere across the galaxy, and we would carry on completely unaware until the instant it arrived. There would be no flash on the horizon, no slow approach. One moment everything is normal, the next there is no next. What happens inside the wall is the strangest part. In the true vacuum, the constants of nature would be different. The forces that bind atoms, the masses of particles, perhaps the very rules that allow matter to exist, would all change. Everything we are made of would simply cease to hold together. It would not be an explosion in the ordinary sense. It would be a new region of space where physics itself has been rewritten, expanding into ours. Stars, planets, atoms, the chemistry of life, all of it depends on the precise laws of our vacuum. Cross into the bubble, and none of it can survive. So should you be afraid? Almost certainly not in any practical sense. If our vacuum is metastable, the calculations suggest the typical time for it to decay is staggeringly long, vastly longer than the current age of the universe. We are most likely safe for spans of time that make a human life utterly invisible. Could a physics experiment set it off? When the largest particle colliders were switched on, some worried they might. But nature already runs experiments far more violent. Cosmic rays slam into the upper atmosphere with energies dwarfing any collider, and have done so for billions of years across the whole universe, without triggering anything. That is a genuine comfort. Every star, every galaxy has been bathed in collisions far beyond what we could ever create for the entire history of the cosmos. If those could nucleate a bubble, it would have happened long ago, somewhere. The fact that we are still here is itself evidence that triggering it is extraordinarily hard. There is an eerie possibility we cannot rule out. A bubble could already have nucleated somewhere far across the universe, beyond our horizon, and be expanding toward us at light speed even now. We would have no way to detect it in advance. But the universe is so vast that the odds of one reaching us soon are vanishingly small. What makes this more than a thought experiment is that the numbers put us so close to the line. If the top quark were slightly lighter or the Higgs slightly different, our vacuum would be perfectly, boringly stable. Instead, it sits right at the knife edge, metastable, in a way no one fully understands. That coincidence nags at physicists. Why should the universe sit exactly at the border between stability and collapse? It might be a clue that we do not yet understand the deeper laws, that some missing piece of physics fixes the balance. Or it might just be the way the dice fell. We do not know. It is important to be clear. We do not even know for certain that our vacuum is metastable. The measurements sit close to the boundary, but with uncertainty, and new physics could push us firmly into the stable region. Vacuum decay is a serious possibility raised by our best theories, not a confirmed sentence. And if it ever did come, there is a strange mercy in it. No suffering, no slow decline, no awareness of the end. The bubble travels at light speed, so the change would reach your atoms before any signal could reach your mind. You would not experience it at all. The universe would simply, instantly be otherwise. For all its drama, vacuum decay changes nothing about how you should live. It is not a looming threat on any human, or even cosmic, timescale we can meaningfully worry about. It is a statement about the deep, far future, and about the hidden structure of the vacuum, not a shadow over tomorrow. What the idea really offers is insight. To even ask whether our vacuum is stable, we have to understand the quantum fields that fill all of space at the deepest level. Vacuum decay is less a prophecy of doom than a probe, a way of testing whether we truly grasp the ground state of reality. It also reminds us how much rests on something invisible. The stability of every atom, the existence of stars and life, all of it depends on the quiet state of fields we cannot see or touch. The vacuum is not a passive backdrop. It is the foundation, and its nature decides what is even possible. Vacuum decay joins the heat death and the long cold expansion as one of the possible fates of everything. But it is the only one that could, in principle, arrive without warning at any instant from anywhere. The others unfold over unimaginable time. This one could, in theory, already be on its way. Yet the overwhelming likelihood is that it never touches us, that our vacuum endures far longer than the stars themselves will shine. The universe has stood for nearly 14 billion years and shows no sign of letting go. Whatever the deep future holds, the ground beneath reality has, so far, held firm. So the next time you picture empty space, remember it is not nothing. It is a quantum field at rest, possibly in a state that only seems final, holding the laws of physics in place by the thinness of a barrier. We live, it appears, on a knife edge, and almost certainly will for ages beyond counting. Vacuum decay is the universe's most patient possible catastrophe, a sword that may hang for trillions of years and never fall, or may already be falling unseen, somewhere far away. Either way, it tells us something profound, that the stability we take for granted is a property to be explained, not assumed. In the end, the lesson is humility. The vacuum, the emptiest thing there is, may hold the deepest secret of all, whether reality as we know it is permanent or merely a long pause. Asking the question forces us to confront how little we truly understand about the ground state of the cosmos. For now, the vacuum holds. The fields rest in their valley, the barrier stands, and the laws that let you exist remain in force, as they have since the universe began. Whatever waits in the deep future, this moment, this stable patch of reality, is yours. And it is, against the odds, astonishingly steady. So we drift on a knife edge we cannot feel, beneath a stability we cannot prove, in a universe that has held together long enough to produce minds able to wonder whether it will last. That wondering, more than any answer, may be the most remarkable thing the steady vacuum has ever allowed.